Okay, so here I want to give you a brief overview of the Functions 11 course, which is the MCR3U course here in Ontario. So this video will be useful for if you want to take the functions course in the future, or if you're currently taking the functions course, because I'm going to talk about the learning outcomes that we expect after finishing this course. So of course this course begins by defining what a function is. So you can think of a function basically as a machine to which we give an input and it gives us exactly one output for that input. That's basically what a function is. So in terms of x and y axis, what happens is for each x value, we should only have one y value. So for example, if we make a circle on the x and y, xy coordinate, that's not a function. Because in a circle, we have for the same x value, usually we have, in a lot of cases, we have more than one y value, more than one corresponding y value. So that's not a function. But think of a linear equation in the form y equals to mx plus b, something like y equals to 3x plus 2. That's a function because that's just a straight line, right? And every point on this line, for each y value on this line, it only corresponds to one. For each x value on this line, that x value only corresponds to one y value. So for each input, there's only one output, right? So that's why this is a function. And there's many ways in which we can determine if something is a function or if something is not a function. In that case, that would be a relation, right? So if something is not a function, that means it's a relation. And more specifically, a function is just a specific type of relation which meets the above condition, which I just mentioned, which is for each corresponding x value, it should only have one y value, right? That's what the definition of a function is. And graphically, one of the best ways to check if something is a function is by using the vertical line test. So we talk about that as well in this course. And then we talk about the domain and range of a function in this course as well. So there's a lot of discussion on domain and range and how to find that, the different notations that we use for domain and range in the course as well. And then, of course, the next step is we talk about function notation, right? So the function notation, by immediately looking at the equation, the function notation helps us to identify if the equation that we're working with, if this is a function or if this is not a function. So for example, if I have an equation, for example, y equals to x squared, right? And determine that this equation is indeed a function, what I can do is I can replace the y in this equation with f of x. So I can call it, I can say f of x equals to x squared. Now, by immediately looking at this equation, I can easily determine that I'm working with a function, right? So that's the function notation. The f of x in here is the function notation. So that's what we talk about next. And the important thing about the function notation is that it helps us think about inputs and outputs, right? On the xy coordinate, it helps us think about what the input is and what the output is. So f of x, inside f of x, the x is going to be our input, right? So we can plug in, and especially when it comes to talking about composite functions, this notation is very useful. And of course, we then begin talking about some algebra, and more specifically, we try to think through quadratic equations. And the reason why we do this is because quadratic equations help us to think about shortcuts in mathematics. Here's what I mean. So when it comes to linear equations are interesting in that we can, so let's think through linear equations first, and then we're going to come to quadratic equations. Linear equations are technically not part of the functions course, but they are in that they appear in different expressions. But we won't explicitly study linear equations. You're expected to know everything about linear equations before you begin this course. So if you're not, you might want to brush up on them before you begin this course. And linear equations are basically equations of the form y equals to mx plus b, right? And we studied them a lot in grade 8 and grade 9 mathematics. So you should be familiar with them. But let's talk about the shortcut aspect of this course that I was about to talk about, and let's compare why we do this using quadratic equations. So in linear equations, how do we graph any equation in the world that we want? We use the best way to graph it, if we don't know much about the equation, if we don't know, like, about the x-intercepts, the y-intercepts, and any of the fancy ways of doing this, what we can do is we can always use a table of values, right? So for a linear equation, we can use a table of values and we can graph it. And similarly, for quadratic equations as well, we can use a table of values and graph it, right? We can do that, and it works for any equation that we want in the world. We can always use a table of values, except that sometimes table of values can be complicated if we talk about some very fancy equations, maybe in 3 dimensions, 4 dimensions, and if you have x, y, z, and many variables in the equation, it kind of gets a bit more involved. But for quadratic and linear equations, it's not all that difficult, but it's not the best way to do it. Now here's what I mean by shortcuts. Even though when it comes to linear equations, we can use table of values with ease, right? It's not very involved to do that. But still, when we learned about linear equations back in the days, what we did is we talked about shortcut methods of graphing them as well, right? So we talked about the slope-intercept form of the linear equation, which is the form y equals to mx plus b. And in this, we used to take the slope, which is m, and we used to take the b, which is the y-intercept, and we used these two numbers to graph the equation, right? It's very easy to use these two numbers and graph the equation. This was for us a kind of a shortcut, right? We didn't have to use a table of values if we knew how to graph the equation using the slope and the y-intercept. Now, the challenging thing when it comes to quadratic equations is that they are non-linear. So, and we need calculus to kind of find the slope of these equations, right? And even when we know the slope, it's not exactly a piece of cake to graph them, even if we know the slope, because the slope is going to be, the slope is not going to be a number as we got in linear equations. The slope is going to, usually a slope is going to have a variable in it, because the slope is changing from point to point, right? So what we want to do here in this course is we want to come up with some shortcuts in which we can graph these quadratic equations. And what we do is we start talking about the idea of translations and transformations. Okay, so what we do is we start identifying what the parent function should be for specific type of graphs. So the graph of x squared looks like a parabola, right? The graph of x squared looks like a parabola. What we start doing is we start thinking about, okay, what if we have the graph of x squared plus 2? How is this parabola going to change because of that? What if we have the graph of x plus 2 whole square? How is this parabola going to change? What if we have the graph of 1/2 x plus 2 whole square? How is this original parent function going to change, right? So this is what I mean by talking about shortcuts, right? Because of course I can take the equation half x plus 2 whole square. I can take that and I can use the table of values and find out what this graph should look like. But that's a lot of work. We don't want to go there, right? We can go there, but it's not very useful. What we want to do is we want to identify in this equation what the parent function is and the different multiplications and additions, the different transformations and translations that are happening in this equation to kind of think about the graph, or to kind of think about how the graph of x squared, the parent function, changes. So this is a significant part of the course. And here I just gave you a very simple example of the function x squared, right? We do this for all kinds of functions. So we do this for the trigonometric functions. We can also do this for exponential functions. But in this course, we don't talk about exponential functions. Yeah, we actually do talk about exponential functions, and we also do talk about transformations of those functions. So that's correct. So when taking this course, you're going to learn about translations and transformations of exponential functions, quadratic functions, and also sine and cosine functions. So that's another learning outcome when it comes to taking this course. And also, there's a bunch of algebra in this course. So you're going to learn about adding and subtracting rational expressions, and you're also going to learn about multiplying and dividing rational expressions. And in my opinion, adding and subtracting rational expressions is much more difficult than multiplying and dividing rational expressions. So But 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 I think what you'll have to if you're good when it comes to solving quadratic equations, that's going to be very helpful when it comes to taking this course. And especially for that part of the course where we talk about adding and subtracting and multiplying and dividing rational expressions. So rational expressions are basically expressions where we have a fraction, and in that, on the top and also on the bottom, we have some expressions, right? So we have something like 2x plus 3 divided by x squared plus 2. That's a rational expression, right? So we can talk about simplifying an expression that looks like that. And we talk about that in this course. And then another part of this course is also talking about the trigonometric functions. So we talk about sine functions, cosine functions, and tangent tan as well. So we talk about that. So basically we talk about sine, cosine, and tangent, all of these functions. And then we also talk about arithmetic sequences. We talk about the distinction between sequences and series. So we talk about arithmetic sequence and series, and also geometric sequence and series. And then towards the end of the course, if the teacher wants to, the teacher also talks about the simple interest and compound interest. And this is very interesting. Because when it comes to the college level course for this, a lot of emphasis is placed on this topic of annuities and simple interest and compound interest. But there is some of that here in this course as well. So that should be a brief overview of what you should expect when it comes to taking the Functions 11 course, and the main topics that you're supposed to cover in this course.